Welcome to Techie Master channel, electrical concepts tutorial 7. So this video we are going to deal about how solar panel works. Okay, so we know that in the modern days we are in the requirement of clean energy to control the pollution and to control the cost of electrical energy production. So because if we go for thermal and other plants, okay, so it will take a lot of cost to generate the power, okay, and also a lot of human power, manpower requirement, and a lot of space, and apart from that it produces a lot of pollution, okay. So day by day we are polluting our world, okay. So the best alternative is the clean energy. So clean energy in the sense solar power, wind power, and hydro powers, okay. So these are all the examples of clean energy. So especially for solar power, okay, so we have very good source of power generation, that is sunlight, okay. So sunlight, it comes always from the sun, so we are making use of it, okay. So basically we use solar panel to produce the electrical energy, so by converting photon energy from sunlight. So how it is getting converted, okay, so it is a simple concept, okay, how the solar panel works. So the picture here you see the solar panel basically has four layers: top layer, bottom layer, okay, and n-type semiconductor, p-type semiconductor in between. So the top layer and bottom layer are made up of a thin EVA sheet. They are just for protecting this n-type semiconductor and p-type semiconductor layer. So this is a basic solar cell, okay. If you take single cell, so it will be constructed like this only, arrangement will be like that only. So why do we use p-type and n-type semiconductor? We know about semiconductor, okay. Semiconductor is a material which lies in between conductor and insulator. So it is not an insulator, it is not a pure conductor, okay. So it is called of semiconductor. Basically a lot of electronic equipments made up of semiconductors like transistors, especially, which is being used elaborately in the electronic field, okay. So why do we use n-type semiconductor, p-type semiconductor? Both are combined, okay. So when we combine both p-type and n-type semiconductor, okay, you see this picture, left side is a p-type semiconductor, positively, okay, doped semiconductor, so which has positive ions, means holes, lot of holes in it, like that n-type right side, which has lot of negative charge ions, that is electrons, which is in orange color. So when we combine these two, so this side electrons moving towards p-type holes, okay, then you see here it is gathering like that. This side, okay, we have positive charges, these are all moving to right side, okay, towards the n-type material. So n-type material, because opposite charges are attracting each other, so n-type semiconductor is always attracting positive ions. So this side n-type semiconductor attracting positive ions, okay. So here it is accumulating like that, this type p-type, here it accumulates electrons. So this green color line is known as depletion region, formed in between p-type and n-type. Once the depletion region is formed, there is no electron or hole movement between these two semiconductor material. So this is a barrier which is forming in between these two semiconductor materials. Okay, so this is the concept of depletion region. So it is basically same thing. How we studied in PN junction diode. So same concept here also it applies. Okay. So we'll see why this depletion region is relating to the solar power. Okay, we'll see in the next slide. So when sunlight is coming from outside, all the way it enters the top layer, and sunlight is transferring through this n type and p type semiconductor. So when it transferring, uh, it it has already depletion region formed as per the concept of this. Okay, this slide. So we have the depletion region formed between n type and p type. So when sunlight is entering to this depletion region, sunlight has photon energy. That photon energy, what it does, it creates electron plus hole pair of combination. So electron and hole pair. So that electron and hole pair, what it will do, electron is attracting towards p-type semiconductor and hole is attracting towards n-type semiconductor. So slowly this n-type semiconductor getting positively charged because n-type semiconductor attracts holes from this depletion region, and p-type semiconductor attracts electrons from the depletion region. So sunlight is continuously coming and it has photon energy. That photon energy continuously creating electron plus hole pair combination, okay, in the depletion region, and the depletion and electron is going to p-type semiconductor, and holes is, I mean positive charge ion is going to n-type semiconductor. So over the period of time, this plate has totally charged with the positive ions, and this has totally charged with negative ions. So when you have a terminal from here and another terminal from here, if you connect one LED bulb between these two terminals, the LED bulb will glow because the current movement from positive ion and between positive ion and this negative charged ions will be having the unidirectional force of electron flow, which causes the LED bulb glowing. Okay, so that's why we use p-type and n-type semiconductor junction here. Okay, so this is the basic concept of solar panel, how it works. The concept is simple. Sunlight is entering to the solar panel, and which has photon energy. Photon energy is traveling through depletion region, and it produces electron plus hole pair, and electron is attracting towards p-type semiconductor and holes is attracting towards n-type semiconductor. So this is the way the charge is accumulating in top n-type semiconductor and p-type semiconductor. So once the charge whatever accumulates, we can take it out through terminals and we can connect our electrical or electronic loads to make use of it. So this is the way the solar power is getting generated in the solar cell. This is the basic operation of one simple solar cell. Okay. So next we see how this, or how we are getting the silicon materials, because the p types and n type semiconductor are made up of silicon material. Okay, so basically silicon is we are getting from sand. Okay, after doing some process, so finally we'll get the silicon, and that silicon will be converted as wafers. Okay, these wafers we use p junction and p type semiconductor and n type semiconductor. So we'll form the solar cell with the help of the silicon wafers. So we are doing some process here, okay, to split the silicon from the sand. Finally we are getting the silicon wafers. So silicon structure basically it will be like this, but when sunlight is penetrating through silicon structure, electron is getting moved in different directions. Okay. This is the reason we use P and N junction. Okay, we are attaching P type semiconductor and N type semiconductor material. Otherwise, we'll have only P type or N type, any one. Okay, there is no need of junction. Okay, uh, because we need depletion region to be formed between P and N junction. Then only the photon energy creates electron and hole pair. That's why we need to combine P and N. So P type alone cannot produce any electrical energy, even though we penetrate sunlight through through it. Like that, N type alone cannot produce the electrical energy when penetrating under sunlight. So we need to have P and N junction. So this is the concept. Hope you understood this concept. Okay, please like, put your comment and subscribe the channel for more tutorial videos like this. Thanks for watching the video. Bye.